Welcome back to HANA Basics for Developers. Now, we've taken a look at XSJS and how it works inside of the XS Advanced Node.js environment. And we've seen a little bit of how the XSJS APIs work, specifically how we can interact with the database with them. But what I want to do in this video is I actually want to show you just some basic concepts of JavaScript and then how they work in the XSJS environment. Because for the most part, I mean, we do have the $ APIs, but the rest of what you do coding-wise in XSJS is really pure JavaScript constructs. So if you already know JavaScript basics from, say, doing SAP UI5 or using JavaScript in some other environment on the client side or the server side, then this unit may not be of all that much interest to you. But on the other hand, if you're coming to this world and you're pretty new to the JavaScript language and capabilities, maybe you're coming from primarily an ABAP background and you've never done much JavaScript programming in general in any environment, then this video is really targeted for you. So what we want to do is, I'm not going to do a lot of hand coding in this exercise. I've already prepared a bunch of samples, and what we want to do is we just want to, we'll just execute them, we'll just walk through the code, and we'll talk about what it's doing. So what I've done here is I've got JavaScript basics.zip. So I've prepared a little zip file here with a bunch of XSJS code that showcases some JavaScript stuff that I want to show you. So let's put it here in the XSJS folder. We'll just do a import. And we'll go grab this JavaScript basics that we just downloaded and put it here. I think this is going to work right. Oh, and it didn't put it in the folder structure that I wanted it to. It's always fun. Dates, JSON objects, strings. I should have looked at my instructions a little bit closer. So we will just cut this and we'll put it in a new folder called JavaScript Basics. There we are. So now we got array, classes, dates, JSON, objects, and strings. So a couple different major categories that we want to look at. But before we can execute all these samples, I'm actually going to need a couple of other things added to my application as well. We're going to need some other services and some other libraries to call to really demonstrate all the techniques that I want here. So let's go grab another file here that's in our ex3. Let's get another zip file. Let's download this zip file. This time I'll try to pay closer attention to where I'm supposed to import this. So we want to come here to our lib folder. Do an import. Let's grab this file. And it didn't create all the subfolders that I wanted, so we'll go ahead and add them manually. Put those in SAP HANA demo content EPM services. Extract that. And what this actually is, this is an interesting thing, because I took a bunch of old XSJS and XSO data content that actually used to be part of the demo model for XS Classic, and I just migrated it over into XS Advanced. And actually, there's very little that you have to do to migrate most XSO data and XSJS, because as we've already seen, it's pretty much lift and shift. The same APIs are implemented, and as long as you don't violate any of the API rules, call an internal API that you shouldn't have anyway, reference a schema, then it all pretty much comes over and works directly. So then we have that there. We're going to reference some of those libraries in our code here. But let's start with the, well, I'll tell you what, let's go ahead and run this. So we'll pick up our newly added code. It shouldn't take that long. It's a lot of new files, but we injected it into the running service pretty fast. And then we have our web module. Let's go ahead and run it. And let's bring this up, XSJS, JavaScript basics. And let's start here with strings.xsjs. Strings, not string. And helps if I put the dot in there that I overwrote. There we are. So what we see here is the output isn't all that interesting. I just wanted to preview to you that it was working once I typed the URL in correctly. But we can bounce back and forth here and look at the output and compare it to the code. In fact, what I'll do here is I'll just, if I'm able to, we'll put them side by side. That's a nice way to look at this. So let's look at this. Let's look at the strings. And actually, let's go full screen there so we can compare as much as possible. And what we see here is, a string is a basic data type inside of JavaScript, and we can use the command var to declare a variable. And actually, what we do here is we're creating a variable. And unlike some other languages, we don't have to declare the type. JavaScript is loosely typed, which means that it take on the type based upon whatever data that we pass into it. So this demo1 variable becomes a string variable because we're going to initialize it with a value that is all characters. So it is a string. And if we were to then output demo1, we see this basic string, SAP HANA Extended Application Services. It takes the variable and it embeds it inside the string. A couple other things that we're seeing here is, we built up this body object. This is also a string that we're just going to concatenate a bunch of things together with. The plus equal sign is a concatenate. It's going to take whatever is in the variable body already and just add more text to it. So you see that's how we're building up the body object here. But also you see, and it can be difficult to see, you might have to zoom in a little bit. Instead of the double quotes or single quotes, we're using the kind of angled quote, and that's a string literal. Very similar in concept. Siggy does this, Java does this, ABAP does this, has the concept of a string literal. And what that allows us to do is embed variables inside the string. That's the $sign and then curly bracket. So this is a case where $sign does not refer to our XSJS APIs, but is a pure JavaScript concept. And we're able to take the variable demo1 and basically concatenate it into the middle of the string. Of course, we could do this as a concatenate command. I could have just done this as separate strings and used the plus to put it together in a larger string. But this is easier to read and easier to maintain when we embed the variables directly inside of the string literal. So this is generally regarded as a better approach than just doing a bunch of complex concatenations. Now, what we see here is if we want to do substringing, we don't have a specific substring command like we do. I'm going to do a lot of correlations here to the ABAP environment because I know many of you are probably coming to this fresh from the ABAP world and maybe don't have experience in JavaScript itself. Over in ABAP, we have the substring command. Here we can just use the brackets and basically treat the string as a character array. And that's essentially what we're doing here is we're saying give me offset 0, so the character in position 0, and these are 0-based indexes. So the very first character would be the 0 index character, in which case it is the letter S. Now we want to get the length of the string. So there we have a lot of commands, functions that are built into the data types. So we can reference them by just taking the variable demo1, and because it's a string data type, we can say length, and that will calculate the length of the string, the actual content that's in the string. So unlike other programming languages where we might have a length command, a length keyword that we then pass in a variable, here those kinds of commands that are type specific, variable type specific, are just inherited from the type of the object when it takes on its type. So a little different than maybe what you're used to there, but actually pretty elegant way of handling things. And then of course a length would be would come back as an integer, and we want to output it into a string. So we can do that. We can say toString to actually take that number and turn it back into a string so it can be concatenated into our body. And that's where we get our 38, our value 38. Now, what do we want to do if we want the last character in our string? Is we can use the slice command to take any part of the string off, and if I would give it a positive value, like if I would say slice and give it a 1, then it would start from the beginning of the string and give me characters. But if I use a negative index, then I'm just telling it to start from the end and work its way backwards. So this also, I think, is pretty elegant, that we can do this forward backwards just by using positive and negative offsets in the slice command. So in this case, this is how we get the last character in the string, which is a lowercase s, by working backwards with the -1. Now, if we want to perform operations to convert the string and the string formatting, once again, not keywords like we have in the ABAP environment where we have the toUpper command as a separate keyword. It is a embedded function of the type. Once again, just like the length and the slice commands, we're going to see that all throughout here with the different data types and the operations that we can perform on them. They just get built-in functions as part of the variable itself. So if we want to convert it all to uppercase or convert it all to lowercase, those are built-in functions of the type. Very, very useful. Now, if we want to search inside the string, this is very easy to do. We use the index of command. So basically to give us the position in the string where we would find the substring HANA. So position 4, remember it is 0 base, so 0, 1, 2, 3 for the space, and then 4 for the start of HANA. So basically it searched the string for all of HANA there, and when it found it, it gave us the beginning index of it. So that's where we got the value 4. Now maybe we want to find the last occurrence of something. So we can say last index of instead of index of. So it has searched the string. Here we're just searching for the letter A, but the capital letter A. So it doesn't find this A in application. It finds the beginning A, and it returns the index of it, 18. And then we can do string manipulation as well. We can do replace, basically a find and replace. And in this case, we want to say replace this entire string extended application services with its abbreviation XS. And that's exactly what we see here. The original was SAP HANA Extended Application Services, and now it's SAP HANA XS. So we've done the replace, and we output it in the body. It didn't actually change the demo1. When we perform the replace, we're taking that output and we're putting it back in the body. We're not directly manipulating the original variable. We would have to put it back into that variable. We actually wanted to change the demo1 variable. All right, the string literals we already have talked about, but just a standalone example. We've actually been using string literals all throughout here. String literals also allows you to do multi-line. So in this case, the string actually wraps around 2 lines, and so one of the other capabilities of string literals. The other thing that I point out here, I said ES6. This is EMCA script 6. So basically JavaScript version 6. JavaScript itself, even inside the web browser, continues to get updated. And we have support for ES6. Basically, ES6 came. I'd have to go back and even check. We've had it for a while. It either came with Node.js version 4 or Node.js version 6. I can't remember off the top of my head. But our latest that we're running is Node.js version 8. We certainly support ES6. So the latest capabilities of the JavaScript language are available here in the XSJS environment. The only thing you'll notice is that our linting, our client-side checking, we do have to let it know that we're using ES6 so that it doesn't throw syntax errors when it sees some of that constructs. If I would take this out from the header here and not tell it that we're using ES6, then it's actually going to throw a parsing error telling, oh, well, that's bad syntax. But as soon as we add back in the fact that we're using newer ES6 syntax, then the client side is fine with that. All right, that's strings. Let's look at another common data type in JavaScript, and that's dates. So let me bring up the date syntax example here, and let's change our runtime so we can look at our dates. Very similar concept here. We declare a variable now, and as long as we feed a date object into it, it becomes a date variable. And in this case, we actually have some built-in functionality to initialize a date. I could have hard-coded a date syntax, but I want to initialize it at the current date. So we just say new capital date brackets. So this is a built-in function inside the JavaScript language itself that will initialize a variable with the current date and time. So it would fill it with a timestamp. And if we want to then output this, I can just take the string literals and I'll take the now variable, and you notice what it does. It turns the timestamp into a nice readable format when I embed it inside a string literal like this. So Tuesday, January 15th, 2019, and the time output in GMT offset, so it knows the time zone of my that I'm in, Eastern Standard Time, and it automatically converted the timestamp into that for me. So that's rather nice. It is 12 o'clock here, 12 p.m. So it did the output. It automatically did the output. I didn't have to do any of that. I didn't have to tell it a time zone. It looked that up automatically. Now, on the server side, I should note, not on the client side, not on my browser. Now, if we want to output specifically UTC, we can tell it to convert. There are a lot of conversion functions on a date, just like we had, two string, two upper, two lowercase on strings. We have similar conversion functions built into the data type when it is a date data type. Now, obviously, if I would do a to UTC string on a string that didn't have a date type, that would throw an error at runtime, incompatible data type. But because we're loosely coupled and we take on the features of the data type based upon the data that we passed in, we have the to date string. To UTC string here. So now we're outputting a UTC timestamp. Notice it's basically GMT, Greenwich Mean Time. So it kept the date and time in that format, and of course the output here is a little different, the order that it appears in based upon UTC specification. We can also do to local date string. So to convert it to just the date and take the time out of there, and it will do the formatting based upon my locale. We know the locale. The browser passes it into the server side when we make the request. So it knows I'm US English, so it's going to format the date accordingly. Same thing with the time. It's going to format the time accordingly here based upon my locale settings from the browser. Same here, locale string. We can say output the whole thing as a locale string, so to convert both the date and the time on my locale and put it all together in a string. We also have ISO string, so this is the ISO format. You'll notice that that's also the format that we use in JSON. It automatically will, if we convert it to JSON, it will automatically use the ISO format internally inside of JSON. Now, something that we quite often need to do is to abstract, pull out parts of a date timestamp. I just want the year, I just want the month, just want the date. In ABAP, I know a lot of us, what we do is we know the internal format that it's stored in, and then we just substring it, and we basically take zero offset, first four characters, and we know that's the year. We don't want to kind of assume the same thing here with dates. We don't want to mess around with the internal format and substring it and expect it to work. Instead, we've got built-in functions that will do the work for us. And regardless of how they, even if the internal format would change, this would continue to work. So we want to get the year, the full year, 2019. We want to get the month. Zero-based index for the month. That's the only thing to keep in mind here. That's maybe a little odd if you're used to January being 1. January is not 1. It is 0. We mostly use zero-based indexing all throughout JavaScript. Day of the week, same thing. It would be a zero-based index for the to get the value of 2 here. To get the date, 15. Day of the month, the 15th day. Now that's not zero-based. When we say the day of the month, it's going to return the actual calendar date, 15. Number of milliseconds since midnight, January 1st, 1970, sometimes referred to as Unix time, since the Unix basically counts the number of milliseconds since it was turned on. And we can get that value with the get time. So to count the number of milliseconds here, we can extract hours, minutes, and seconds as well from our datetime object. And that's the other thing that you'll see here. We don't really have a separate datetime object. We tend to process things as a date object, and we can extract the hours, minutes, and seconds from it. So everything's very timestamp based. Once again, if you're coming from the ABAP world where we have a timestamp, we have a date object, we have a time object, not so much here in the JavaScript world. We also see here we can force formatting for different international time. Oh, I'm sorry, skipped one here. If you want to do math on timestamps, it's very similar to the ABAP environment. You can just add to it. So in this case, I've got a date object, and I want to just add 30 to it. That's going to add 30 days to it, and then I output. So next month, 30 days from now will be February 14th at this particular time. It's going to do all the internal calculations. It knows how many days in a month. It knows leap year and stuff like that. I don't have to account for that in my calculation. It's smart enough to do all that for me. And then finally, some international formatting here. If I want to force certain formats, for instance, I'm going to take a date and I'm going to tell it to force the US format. Basically, I have to take the locale encoding here, ENUS, and then I'm going to force German encoding, and I can output both, so I don't have to rely on the customers or the client side encoding coming from the browser. I can force a particular encoding here, and you see dates being formatted according to the US format and according to the German format. Okay, so that's dates. Next, let's look at arrays. Let me change my runtime. There we are. Lost my mouse there for a minute. So let's look at arrays. Oh, I actually have a little bug here in my code. Let's just fix that real quick. I'll have to fix that on the GitHub repository. So you're seeing this in real time here. I didn't actually call the function. That's why we're not seeing anything in the page. Let's just go ahead and restart that real quick so we can see that. And Now, there, that's what we expect to see. So I need to fix my source code on GitHub. I'll do that right after I'm done recording this video. But let's go back here and let's talk about arrays. So for those of you who come from the ABAP world, we're obviously used to internal tables. And arrays are not quite like internal tables. It's similar. It's more like almost more like a structure of data. We can keep different elements and we can access and loop over the elements. We can access the elements by name. We'll see here in a minute how objects, and particularly JSON objects, are closer to the concept of internal tables. But what we see here is we want to build an array, and we can do that just by comma separated values inside of a bracket, and each one of these items then will be its own separate item. So we've got red, green, blue. You can kind of ignore this font color. What I wanted to do is I actually wanted the whatever name we're giving out here, like red, green, blue, it actually appear in that color on the client side. So I'm just doing some embedded HTML here to kind of make this look a little nicer on the client side, but don't get caught up on all this font color stuff. But what do we wanted to do here is we wanted to build two arrays. Our first array is going to have red, green, blue in it. We're going to build another array that later will combine the two together with black, white, orange, and purple in it. All right, and we're going to begin just by outputting the entire array. And if I say toString, it doesn't output, doesn't take the literal string here of the brackets and stuff like that and output it. It's actually outputting the individual values separated by commas. Here, if we want just the first element, we can use the bracket and an index, being zero based. If I want the first index, the first one in this order, I get just red when I ask for 0. I can get the number of elements, just like I did get the number of characters. I did a length on a string variable to get the number of elements in an array is the same length, and that's because earlier when we did, when we processed the string, we were basically treating it as an array of characters, where every character position was its own index in the array. Well, here an array can be a more complex object, and not each individual character, but each individual element that we're passing into the array separated by commas. All right. And similar, you're going to see some similarities here because we're basically reusing the same functions that we did with the characters and the strings in the first part. We can say index of blue, and it's going to search for a value that has blue, and it's going to pass out that number. Now, it actually didn't find it because I don't have a value blue, because my value would be font color blue. With all this text, I would have to search for that entire thing. So it returned a -1. And that's okay. That actually means -1 in this case means I didn't find a value. And if I were to now change this so that instead of blue, it was actually this whole font string, let's put that in there and save that and rerun it. And then refresh our web page. Now, instead of -1, it found it. It found the value of blue, the third element, so 2. Remember, zero-based index, so that's why it has the value of 2. Now, if you wanted to loop over all the elements in an array, a pretty common way of doing this is the for loop. So basically, we're setting up a for loop, and we're creating a new variable. That's what the let command is. It's very similar to the var command, except a let command will create a variable only within the scope of this operation. So this variable will only be created and initialized within the for loop, and then it would be destroyed and no longer accessible as soon as we exit out of the for loop. So better scoping of the variable, if you will. And we're basically saying create a variable of colors, so this array of colors. So what it does is this is just like doing a loop on an internal table, but instead of each record in the internal table, in the ABAP speak, it's doing it for each indexed item in this array. And then we can output them one at a time, and that's what we see here, red, green, blue. Next, we see if we want to combine two arrays together, we can do a concatenate command. And that will take all the values of the original array and just add in all the values of the other array that we have here. So that's where we get our red, green, blue, black, white, because it appears in white and we have a white background, orange and purple. And then we can do sorting on our arrays. Similar, you could sort an internal table. This is where I said it's kind of like an internal table, but we actually don't have this kind of flexibility in the ABAP environment to do this on, the closest thing we have is like a structure. But this would be like, it's almost like creating an internal table, but where instead of each record, it's each element that we have in here. So we can do sorts on them. So we just say reverse or the sort command. Once again, these are built-in functions based upon the type of the object that we're performing it on. If we want to remove an element from the array, the command is pop. Pop it off the stack. To kick it off the stack, that's where the pop command comes from. And if we want to remove the first element, then it's a shift. Now a shift is a destructive operation, unlike in the ABAP world where a shift would rotate the first element around and move it to the end. In JavaScript, a shift will move everything over and it will destroy or drop the first element. Okay, so that's how we can actually remove an element is using the shift. Now if we want to copy out a specific section, we can use the slice command. And basically we just give it a starting index and then how many elements do we want to take out. So in this case, if we want to slice out the third and fourth element, we can do that by saying the start and end of the slice command. We want to add elements in, but do it at a specific position. Then basically we use the splice command, and we're saying here that we want to splice. We would give it the index where we want to start the splice, the number of elements that we want to splice in, and then the actual element values. Okay. And then if you want to add an element at the beginning of the array, we use the unshift command. So the shift command removes the first element, and unshift, we give it a value, it shifts everything over and inserts a new element at the beginning of the array. And of course you can, I'm not showing you each one of these items as we're talking through this. You can of course look over here at the other side as well. Come back and restudy this video if you want, or pull these source code samples into your own system and have a look at them. Next, let's look at JSON. We've already seen JSON as the return, the way the data is returned from the database, and as we've already seen, it's a pretty close equivalent, like I said, to the ABAP internal table. Major difference here, we're selecting from the database, it's returning a record set. The record set returned from the database query is automatically a JSON object. And we can loop over JSON using the same for command. This is basically loop at a table into. This is equivalent syntax in the ABAP world, where record set is our internal table and item is our into. It's our single item. And then if we want to do some processing here, we can update. That's what we're doing here. So we're actually taking the gross amount minus the gross amount times 10%. So we're giving a 10% discount, and then we can just put it right back into the JSON object. We don't need an append or modify or anything like that. It's just automatically going to perform the operation. And in this case, discount amount wasn't even an original column in the database. That's not coming out of the database. We're creating it on the fly as we loop over it. So that's where JSON is a bit more flexible than ABAP internal tables. We can actually create columns on the fly. And that's also why what you see here is in the actual data output, we don't just see the values in the output. This isn't a display construct, this is actually in the raw data, is we repeat the column names over and over again. And yes, it adds some overhead to the data transmission and storage and processing, but it allows us to have variable structures at each item inside this. So we're basically creating an array of items structures, and although in this case they have all the same structure, they do not have to have. So that's a very powerful part of the JSON construct. Now we can basically take JSON and bring it together with the construct of objects in JavaScript. So let's change here to objects, and let's make this bigger. So an object is bordering on the level of object-oriented. It was perhaps what you might say is the first attempt to bring object-oriented concepts into JavaScript, but it is not quite a full object-oriented kind of object. It does not have all the semantics of a class, all the concepts of inheritance and polymorphism. We'll see in a second that actually JavaScript has added true object-oriented. But this object is kind of stuck in between historically. It's not quite an object-oriented object, but it's not quite not an object-oriented concept either. So you see we can build an object, and basically using the squirrely brackets here, that defines an object, and here we have almost like attributes of the object. This is where it's like object-oriented, and we can declare inline functions that are part of the object, and that becomes almost like a class method, but as you'll see here, not quite like that. We have the ability to output an object, just giving it the object name dot and then the named variable. So colors.red is going to output that value. We have the ability to have regular data types here. Data variables themselves are actually objects, and we can assign them by reference, similar to objects within the scope, variables within the scope of an object in a sort of object-oriented fashion. So we see here that we can fill in the new value and change it to first value, and we can have the scoped value here. So you can kind of study this on your own. I think it helps, even play around with the values and see what they look like. We even have a pseudo constructor. We have the ability to create a function here where we create a purchase order object, taking in a purchase order ID, and we'll go, like in this case, get the data from the database for that. We can even this.discount, so we extend the object from within itself and add another attribute to it that didn't come from the base. And we have the ability now to create new object instances. So I'm going to create a PO instance by saying new purchase order. So we're really just creating an instance of a function in this case. We're passing in a value. And then we can treat it kind of like an object instance in object-oriented constructs. PO purchase order ID is going to output the value for purchase order 0, and then the same thing with purchase order 1. But at the same time, it's not exactly object-oriented. Like I said, we can attach functions, we can add additional attributes, but there's no inheritance, there's no public-private really. So, like I said, this was like a first attempt, and so some of the people will even say this is sort of a abuse of the construct of an object to try to turn it into object-oriented, but you can kind of do that. But let's look at the fact that now in JavaScript and ES6 we have true classes. Basically we've recreated the object that we had in the previous example, and we've done it as a real class, in which case we use the the new syntax here of class to actually declare a class, and we have a constructor function, a true constructor, and we can add additional functions in here, and we have the full concepts of public, private, inheritance, polymorphism, things like that. We'll actually later in the exercise, when we move on to Node.js, we'll cover more of this functionality. We'll actually use the class-based approach to do some of our custom coding in the Node.js world. For now, I at least want to make you aware of it. And this is a similar construct to the way that we accessed the earlier item, but as I said, now with the proper object-oriented constructs and the dedicated syntax for creating a class and constructor and things like that, without having to sort of abuse the JavaScript object and turn it into something that it probably wasn't intended to be. And with that, we'll close out our discussion of JavaScript language basics. Hopefully, if you are new to the JavaScript world, this has helped you begin to learn some JavaScript. And it's really just the start. In a short video, I can't teach you everything you need to know about JavaScript, but I really centered this particularly on ABAP developers, and I hope this will help you take your existing ABAP knowledge and skills and see how you can pretty easily transition and reuse many of those same concepts in the JavaScript, XSJS, Node.js kind of programming environments.